Oh, yes. Okay, so this is additional physics help on 12.3. So additional help after school 12.3. Looking at number 30 in the chapter review, if you have one object that's being dropped straight down, which has a VI equal to 0, and acceleration of negative 9.81 meters per second squared, and you have another object here, which is pushed off of something, kicked, flicked, or pushed, from the same height, has a VI y equal to 0, an acceleration of negative 9.81 meters per second squared. Which one will hit first?
Same.
Bingo!
Even if it's like shot from a gun?
Absolutely. Because as long as the gun is perfectly horizontal, because all of that initial velocity is on the x-axis. Now, if you tip it up or tip it down, all bets are off. It's a whole different problem. Because then VIY is no longer equal to 0. But, yeah, if VIY is equal to 0, they're going to hit the ground at the same time. Okay. Tell you what, hold on. Okay, so this is page 104, number 5, and we've got a football being thrown to a stationary receiver, thrown at an initial angle of 40 degrees. I'm ignoring sig figs right now. And it needs to reach somebody's hand, somebody's three-fingered hand, that is 31.5 meters down the field. So what we want to know, two things. Number one, what VI is necessary to get it there. And number two, what's its delta Y max? So we start off with our usual shtick of listing all our variables. VIX equals cosine theta VI, VIY equals sine theta VI. The x displacement that we want, so we're going to look at the first part first, is 31.5 meters. Now, what's our y displacement on that overall flight path? 0. So delta y for that first problem is a big old 0. We know acceleration, negative 9.81 meters per second squared, and I suspect strongly that we'll be using delta t as a bridge again. So let me move this whole thing. So for that first problem, what VI is needed? Let's start off with VIX equals delta x over delta t, and let's do over here delta y equals VI delta t plus 1/2 a delta t squared. Okay, so there's one thing we can do immediately which makes life a little easier. And this is VIY, of course. That's 0. So that means we have 0 equals VIY delta t plus 1/2 a delta t squared, which means we have negative VIY delta t equals 1/2 a delta t squared. This is very much the approach we took with the other one where we had no initial velocity, if you recall.
How is 0 again?
Because it's being thrown from this person's hand to this person's hand. So we're assuming it's 0. It's going to have an overall y displacement. It's on the same.
Go off. Okay.
Yeah, I mean it goes up, but it comes back down. It's at one height. That's badly drawn, but yeah, it stays on one level plane. Okay, so at this point, I'm going to take some of this stuff. Well, let's get this expression solved for delta t. So delta t is delta x over vix. So what's vix? Well, it's vi cosine theta. Delta x over vi cosine theta. Okay. And viy is, so we have negative 1 vi, whoops, sine theta delta t equals 1/2 a delta t squared. So I'm going to take that and move that to the next page. Okay, so we're ready to do some substitutions. So negative 1 vi sine theta times, oops, that's delta x vi cosine theta. Move that over a little bit. Equals 1/2 a, and then we have delta x over vi cosine theta. Let me move this again. Okay, so now you're ready to do some big bad algebra. Negative 1 vi delta x sine theta over vi cosine theta, well, equals, let's see, a delta x squared over 2 vi squared cosine squared theta. Okay, what do you see right off? I see a chance to get rid of one of those vi's. So those go away, and it's pretty much all ugly algebra from here, solving for vi. At this point, it's just hideous, hideous algebra, which I love. So, you know, the question being, if you're looking for something else, like delta x or delta y, whatever the thing you're looking for, if it crosses the axes, like vi has a component on the x-axis and the y-axis, you're going to have to join the motion on the two axes somewhere. You know, big broad questions like, if this person jumps, do you make it? That obviously is going to require, because you're looking at a position in time that's got a location on the x and the y-axis. Those are going to require marrying the two axes. Things like maximum point in flight, those don't, because you can look at the motion on the y-axis alone, just like, you know, the thing dropped versus the thing kicked off the edge. We can analyze its y motion independently of its x motion. So, do you feel comfortable doing the big bad algebra here? You've got a trig identity, which could simplify your life. Okay, so that's from there. Okay, I think I bumped pause there. It's from here, it's just algebra. You should be able to get it. Remember your trig identities. Remember all of your order of operations stuff. For the second part of the same problem, what is the maximum height of the ball during its travel? Let's go back and pick up some of this information. Copy. Paste. Okay. So now we want to know the delta y max. Well, for this, we can look at just the y-axis, because this is something that's occurring on only the y-axis. We can analyze the motion on the y-axis completely independently here. So we know that for that point in the trajectory when it reaches maximum height, we had a VIY, we have a VFY, which is 0. So at that point we've got VFY, VIY, A, and we're trying to find delta y max. So we can either use, if you want to really be ugly and, you know, technically beautiful, use that entire stupid expression that you just created for VI. Nobody in their right mind is going to do that. You're all going to take the VI that you just used and put that in. But you can use, I mean, it's technically beautiful, and if you really love tearing your hair out with algebra, go home and do that over a cup of hot chocolate. But most of you won't. I wouldn't, honestly. So with those 4 things, what equation can you use? I believe that's the expression. Yeah? Comfortable with that? And comfortable, more importantly, because you have the right question, like, well, what if I'm doing this? Well, how can I do this? If it's something that is happening sort of discretely on the y-axis, you can analyze it only on the y.
So we're just looking for delta.
You're just looking for delta y. This is going to be delta y max here because you've set that VFY as 0, which puts you at top of flight. That's what says mathematically we're at the, yep, that's it. That one's pretty easy. So you should have this rearrangement. Now, here's the thing to remember. This is 0. This is VIY. What's VIY? It's VI sine of theta. If you use the entire initial velocity, you're going to get the wrong answer. Because you're only now looking at the component of the initial velocity that's on the y-axis because you're isolating the motion on the y-axis. Does that make sense?
Yes.
Yes, maybe. Yes, but I don't like it.
I understand, like,
Okay.
like in this.
Okay. Okay, so with that, you should be able to do it. Don't forget your negatives. Don't forget to square things. And that'll give you your delta y max.
6.61.
Yeah, 6.61. Yep.
So accomplished trying to do this
I
right.
know, isn't it a great feeling? Okay, 34 is kicked, flicked, and pushed. So we have a ball thrown horizontally. See it? And we're told that if this ball were thrown purely horizontally, it would, at a displacement of 18.3 meters, it would have fallen 0.809 meters. So that would be a negative displacement. There's our little baseball. So we can do our x and our y. Delta x, delta y. In this case, VIY equals what? Because this is kicked, flicked, and pushed.
-9.
I was doing like cosine,
Because this is horizontal. So there is no VIY, which makes your life so
So
easy.
we're looking for the VIX.
You're looking for VIX, which is equal to the whole VI. So, and that's it. It is hard to toggle back to the easier problems, honestly, after you've been doing the harder ones. You're like, no, there's got to be more to it. It's got to be more complicated than this. Nope, it's not. Okay.
realizing, oh, this is an easy one. I would just
Yeah.
like,
And of course, we've got no acceleration on the x. We've got acceleration on the y, negative 9.81 meters per second squared. Delta t will form our bridge. You want to try that one? So, we know we can do VIX equals delta x over delta t. Over here, we've got delta y, VI, a, and delta t. Well, what about delta y equals VI, y, delta t, plus 1/2 a delta t squared? And we know that this goes away. So we have delta y equals 1/2 a delta t squared. Now, if we rearrange that to delta t equals delta x over vi, we've got something we can plug in. And we want to solve for vi, and that'll be relatively easy at that point. It'll just be ugly algebra. Okay, so to get over that one hump, let's take this whole mess and redo it over here. 1/2 a, well then it's delta x over vi quantity squared. And then you'll just do the algebra. So, and this is a derivation we've done a lot. That's your what, 2a delta y over delta x squared square root equals vi, I think. I think I've done that derivation enough times I can almost do it without looking. And once you write it, you're like, oh, that. Right.
It's completely forgot.
Yeah.
No longer.
Right.
Okay.
And it's actually helpful for you to toggle back and forth between the older stuff and the newer stuff, because on the test, of course, you'll have both kicked, flicked, and pushed,
Yeah.
and
Is
angled
the
lunge.
delta x on the bottom, is it square?
Yes, it is. It's just badly, badly written. Okay, I just did some of the worst algebra ever done in the history of this room, I hope. And my dear students let me get away with it. Nope, 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 nope. Okay, so let's do this the right way. So 2 delta y, sure. But we divide by a, so now we're down to delta x squared over vi squared. Because here we were multiplying by a, so we got to divide by a to move it to the other side. So now we would have 2 delta y vi squared over a equals delta x squared. So to rearrange those, we would have, let's see, multiply both sides by a, so we get 2 delta y vi squared equals delta x squared a. Divide both sides by the 2 delta y, so vi squared equals delta x squared a over 2 delta y. Take the square root of that. So basically I had it completely reversed. What a goofball. Okay, so that one's kicked